Hi everyone, Morgan continuing on with the idea of Hess's Law here, page 5 of the lecture outline. Now, we talked about this problem previously, but we looked at it as kind of a pathway diagram, okay? Now what we're going to do is we're going to look at it from the point of view of a classic Hess's Law problem involving thermochemical equations and a bit of a puzzle, so to speak, how to put everything together the right way. So when I look at my goal equation, 2NO plus O2 gas, and 2O4 gas is the product, I come up here and I say, what's useful? In this first equation, I see the N2O4 gas. I want that on the product side. Here it's on the reactant side. Fine, I reverse it. 2NO2 gas gives me N2O4 gas, and my enthalpy change is now negative 57.20 kilojoules. When it was written this way, it was endothermic. So if I'm writing it the other way, it's got to be exothermic. I can think of, endothermic plus energy because the delta H is positive. So if I reverse it, the energy is going to be on the product side. All right. In this next equation, 2NO plus O2 and 2NO plus O2, I'm looking for that. I'm going to use this as is. Since I did not change the equation, I am not going to change the value of the enthalpy change. Now, just like in algebra with systems of equations, you're going to see those cancel. And I'm left with 2NO gas plus O2 gas to give me N2O4 gas, and these add together, and I get negative 171.34 kilojoules. And that's your typical Hess's Law problem. Now we're going to move on to look at question 2, where I'm presented with 3 equations, and don't worry about that. Typically, if you have a problem that has 3 equations in it, one of them is just there to make stuff cancel. So, here's my goal. What does this first equation give me for my goal? It gives me HCl. It's on the wrong side. So I'll go NH4Cl solid to give me NH3 gas plus HCl gas. The delta H naught is now positive 176. But I need 2 of those HCl's, don't I? So I'll multiply this by 2, I'll multiply that by 2, I'll multiply that by 2, and the value of the delta H gets multiplied by 2. Now in this second equation, H2 could be helpful, NH3 could be really helpful for making that cancel. So I think I'm going to reverse this for this equation. Put the NH3 first. 2 NH3 gas gives me N2 gas and 3 H2 gas, and my delta H naught is going to be a positive 92.22 kilojoules. Cool. This equation is great because it's got H2s and Cl2s on the same side. I can use that. N2 gas plus 4 H2 gas plus Cl2 gas to give me 2 NH4Cl solid. I did not change anything in the equation, so I'm not going to change anything in the value of delta H. Now immediately I see the NH3s gone. Oh, and actually the NH4Cls are gone. The N2s are gone. Now I've got 3 H2s as a product and 4 H2s as a reactant. So all the product ones are gone, and that's just going to leave me 1 over here. H2 gas plus Cl2 gas to give me 2 HCl gas. And when I add up all of the delta H's there, I get negative 184.64 kilojoules. All right. So, do another one, okay? And this one is going to turn out slightly different just for convenience. You'll see what I mean. C2H2 gas, 2H2 gas to give me C2H6. Now, I'm seeing 2 C2H2 gas here. I'm going to reverse that equation. 2 H2O liquid plus 4 CO2 gas. I can write them in either direction. Well, hold on. Actually, no, I'm sorry. I don't need to do that. They're already on the same side. I'm just going to use it as is. 2 C2H2 gas plus 5 O2 gas to give me 4 CO2 gas, 2 H2O liquid. Delta H naught is not going to be adjusted. It's negative 2,600 kilojoules. Now I realize I only want one of them, and here's 2, but just play along with it for a moment. You'll see. All right, now C2H6 I need on the other side, so I'm reversing this whole thing. 4 CO2 gas plus 6 H2O liquid to give me 2 C2H6 gas plus 7 O2 gas, and that's going to be a positive 3120 kilojoules this time. Positive because I reversed it. Now, this third equation is going to be good for getting rid of things, okay? But it's also going to be good for giving me the H2 that I need. I need H2 gas, then I've got plus a half of O2 gas to give me H2O, which is a liquid, and this delta H is negative 286 kilojoules. But since I need 2 of these H2 gas, I'll multiply that by 2, multiply this by 2, that makes 1, and multiply that by 2. So I see some things that are going to cancel. All right? I've got 4 CO2 gas and 4 CO2 gas that cancel. Now, waters. Okay? Here I've got 2. Here I've got 2. Okay? So 2 and 2 is 4. Over there I've got 6. You know what? I need 2 more waters. I'm going to now, instead of multiplying this by 2, I'm going to multiply it by 4. So that gives me a 2 on the O2, and that gives me a 4 on the water, and this will get multiplied by 4. Now it'll work out. The 2 H2Os and the 4 H2Os make 6, which cancel those 6 there. Okay, so that's good. Now these 5 O2s plus 2 O2s make 7, which cancels those 7. What that leaves me with is 2 C2 H2 plus 4 H2, both of those as gases, to give me 2 C2 H6 gas. So what I'm going to do is just divide that whole thing by 2. And when I divide that by 2, I'll take the number that I got here, which was negative 624 kilojoules, and I'll divide that by 2. And that'll leave me with C2 H2 gas plus 2 H2 gas to give me C2 H6 gas and a delta H naught that equals negative 312 kilojoules. Okay, so I'd like you to go now and try to do the 3 problems on the next page on your own, and then we'll tune back in the next video to see how you've done. All right, this is Morgan signing off.